When configuring multiple spanning tree protocol, you will create a region. Now, what is a region? Well, a region is a collection of physical switches within that physical topology that share and view that same physical topology the same way. And then within this physical topology, within this region, we are going to break it up into logical spanning tree instances. So we might break it up into 3 spanning tree instances within that same physical topology. So what has to match inside of a region in order for those switches to be considered part of that same region and ensure that they can exchange successfully that spanning tree information and view the logical topology the exact same way? Well, first and foremost, the switches are going to need to be configured with a region name. So in this topology, we can see that we have region A created and region B created. So you can have multiple regions inside your physical infrastructure. You don't have to have every single switch in your topology in that exact same region. You might want to break it up into different regions based on how the physical topology is set up and organized. You might want to do that. And if you have to provide communication between the different regions, you can. However, you want to try and keep it as simple as possible. So if you can get away with one region and make it work that way, then go ahead and do that. So on the left-hand side, we have region A. We're going to give it a name of A, okay? We might want to be a little more descriptive than that, but every switch has to have that same name. We will specify a revision number. Now notice what I said, specify a revision number. It is up to you to identify that revision number. So let's say we choose revision number 1. Every switch has to be configured with revision number 1. The purpose of the revision number is to keep track of the changes to the MST configuration. However, it's not a dynamic process. So if you make a change, the number doesn't change automatically. It's up to you to manually change the revision number. However, if you change the revision number on one switch, you have to change it on all the switches within that region, or else they're not considered to be part of the same region and therefore will not successfully build the spanning tree topology as it should. And then lastly, the VLAN association table. Now, what is the VLAN association table? Well, it is the table that describes the number of instances we have and the VLANs that are members of that particular spanning tree instance. So let's say we have 3 spanning tree instances that we create, instance 1, instance 2, instance 3, and we place VLANs 1, 2, and 3 inside of instance 1. We place VLANs 10, 11, 12 in instance 2, and we place VLANs 20, 21, and 22 in instance 3. Well, this table will have to be the same on all of the switches inside of the MST region. If it's not, then they are not considered as part of the same MST region, and therefore the spanning tree topology will not be created successfully amongst those switches inside of that MST region. So how does this information get propagated? Well, it is up to you to configure it. It doesn't get propagated dynamically, so you configure the name on all of them, configure the revision number on all of them, configure the VLAN association table on all of them. However, if you are using VTP version 3, VTP version 3 does support the propagation of that VLAN association table for those switches that are in the same region by name and have the same revision number.